Now, let's move on to an example AP problem. You are initially given the polar function r of theta is equal to 3 theta plus sine theta on the interval 0 to 2 pi. As soon as you see a problem with a polar function, it's best to put together a graph. Since this is a calculator-approved problem, switch your calculator into polar mode and take a look. It should appear as a counterclockwise spiral with unit circle style theta coordinates. Let's look at what's being asked. Part A says to find the area under the curve in the second quadrant. Part B deals in polar rectangular conversions. And Part C involves rates of change in a polar function as relating to rectangular positions. At this time, take a few minutes to pause this video and try it for yourself. The question for Part A is to find the area in the second quadrant, which the graph really helps with. The function's graph lies here for values between pi over 2 and pi. Now, use the polar area formula, the integral from a to b of 1/2 times that function's squared d theta, using those as the limits of the integration and the function as r of theta. Manually integrating, involving the listed processes, is easy, but results in this mess of a function, which I call capital R of theta for simplicity. You can just use your calculator instead, though, and get that the area is equal to 47.513 square units. Part B uses these two conversion formulae, x is equal to r of theta cosine theta, and y is equal to r of theta sine theta, in order to get rectangular coordinates from polar ones. The question asks you to first find the theta value for which x is equal to 3, so use the first formula with that x value. Again, using a calculator is nearly required here, so use the solve function to get the theta that lies between pi over 2 and pi. This should be 2.01692, and keep that full value, we'll need it in just a bit. Next, we need to find the y value at that theta coordinate, so simply plug that theta value that you saved back into the second conversion formula to get y is equal to 6.272. Make sure that you have your decimal places correctly. 3 is required for the AP test. This final section brings us back to derivatives. We must now find the rate of y-coordinate change over time, given that the change in the theta value is 2 per time period, specifically at the time when theta is equal to 2 pi over 3. Simply differentiate the y conversion formula to get dy d theta, as shown, but we need dy dt, not dy d theta. Since the derivatives work on similar properties as do fractions, one can multiply dy d theta by d theta dt to get dy dt, as in accordance with the chain rule. Therefore, simply multiply dy d theta by the d theta dt value of 2, and plug in theta is equal to 2/3 pi, so you can find that dy dt at that time is equal to negative 2.819. This question also asks for interpretation, so one can explain that the negative rate for y simply means that the y-coordinate decreases by that many units in whatever time period is specified. Here's the full solution write-up and point distribution, in case you missed anything. You're going to need the integrand in this function for area, also known as just the function they give you for r of theta, and make sure that you square that, of course. You'll also need to make sure that you have both of those limits correct, pi over 2 and pi, as well as the constant 1/2. The final point is allocated simply for getting the correct answer to the correct number of decimal places. Part B requires that you know both of those conversion formula, and then plug in just the negative 3 for x. This should allow you to then find the value of theta for the second point, and then you'll just plug in that theta value back into y and get the third point. Again, that it will require you to save all those values so that all the decimal places are as required. After you've used the y conversion formula and its derivative, you'll have to show that you use the chain rule by multiplying dy d theta by d theta dt. This will get you dy dt, which you then evaluate using the given theta value. After that, you'll just have to get a point for the answer itself, and then for the interpretation that we discussed earlier.